Hello all. We are now learning how to actually analyze a circuit and find values like voltage, current or power. They are two important types of analysis, nodal analysis and mesh analysis. In this lecture, we will start with nodal analysis. Nodal analysis is a type of circuit analysis that makes use of node voltages as circuit variables. It is usually more convenient to use than the regular Kirchhoff's law analysis learnt previously. This is because it produces less equations. To use the analysis, follow these steps. Step 1. Select a node as a reference node known as the ground. The ground branch looks like this in a circuit. It has a node voltage or potential of 0. It's usually placed at the bottom of a circuit diagram. Step 2. Assign variables to the rest of the nodes. Step 3. Apply Kirchhoff current law to the all other non-reference nodes to get equations. Using Kirchhoff's law, we know that we will obtain the currents approaching and leaving a node. For a resistor, current flows from a higher potential to a lower potential. The higher potential being the node before the resistors and the lower potential being the node after the resistor. The formula as shown is used in nodal analysis to obtain the current of a resistor. Last step, step 4. Solve the KCL equations to obtain the values of the node voltages. Here's a circuit to explain the steps. A reference node or ground has been assigned. Remember that the ground has 0 potential. The rest of the nodes have been labeled. Some of the nodes are labeled 0 because the nodes after the ground nodes are the same. This is because no elements are present to contribute a voltage change. But you should already know why from the past lesson about labeling nodes. All currents entering and leaving each non-reference node have been labeled. Expand the current equation of the resistors using the formula from before so it can be used in the KCL equation. Using KCL and the currents from all elements, find the equations. Finally, connecting and solving the equations is what you will do if we had values. So let's move on to an actual example. For this example, start with the steps. Since the ground has been placed, move on to the next step. Label the non-reference nodes. Label the currents entering and leaving the non-reference nodes. Find the current of the resistors using the formula from before. Now find the KCL equations. Simplify the equations. Use the equations found to find the values. We have two equations. These will be used to find V1 and V2. Solve the simultaneous equation. That will be all. When voltage sources are involved in nodal analysis, two cases can arise. Case 1. There is a voltage source between a reference node and a non-reference node. In that case, the voltage source at the non-reference node is set to the voltage source, which in this scenario is 12 volts. Case 2. There is a voltage source connected between two non-reference nodes. The source will turn into a node. Specifically a supernode. All the currents entering and leaving the non-reference nodes will now enter and leave the supernode. Taking multiple KCL equations and forming one for the supernode. In the circuit diagram, there is a voltage source between two non-reference nodes. The voltage sources turns to a supernode. Here is the KCL at the individual nodes before the 12-volt source becomes a supernode. Here is it also after the 12-volt source becomes a supernode. Problems involving supernodes go the extra step and make use of the KVL around the supernode loop. The KCL and KVL equations will be used to find the node voltage values. Here we have V1 to be -6 volts and V2 to be 6 volts. This example explains how to solve supernode problems. Start off by placing the ground and labeling the non-reference nodes. Also label the other resistor currents. Remember that when a voltage source is between the reference node and the non-reference node, the non-reference node source value will be equal the voltage source value. We found V1 to be 21 volts, so there will not be need to use KCL to find an equation for that node voltage. Now find the current of the resistors. There is a voltage source between two non-reference nodes V2 and V3, so the source will turn into a supernode. Since the supernode will now be the only node we have to deal with in this circuit, let's find the KCL equation. An equation has been obtained, but as you can see, it is not enough to get values. We will now find the KVL equation around the supernode loop, which is the middle loop. Remember, the KVL equation will make of node voltage variables. Now we have the second equation to use in completing this exercise. Use both equations to find V and I. Remember, I3 is I from the original circuit diagram. V is the voltage of resistor 3 or V2. V equals -0.6 volts and I equals 4.2 amps. With that, comes an end to the lecture. Thank you all for listening. That will be all. Later.